Our science panel today is our moderator, Dr. Tiffany Troxler, Dr. Harold Wanless, and Dr. Jayantha Obeysekara. We like to call him.
Basically in concert, sea level was dropping down in the ice ages and coming back up about 100 meters. So 100 parts per million up and down of CO2, 100 meters of sea level up and down. That's how we naturally presented ourselves to the sun. Well, then we started the Industrial Revolution, and we had another thing happen. We had the population start to increase. And I love this next picture because it was taken before there were 2 billion people on the planet in 1940 on Coney Island, 2 years before I was born. I think all the people on Earth were in that photograph. I love that picture. But here it is where I was born, and the little arrow on the left, less than 2 billion people. Now we're about 4 times that. We're at 7.7 or maybe 7.8 by now. 4 times increase. In concert with that, we have kept the Industrial Revolution going, and we first went from wood and peat to coal, and then to oil, and then to gas. And we've had a 7-fold increase, but at the same time, we're using more and more efficient fuels. So it's more than a 7 times increase in the amount of energy we are producing. So we're living a very comfortable life, and we're paying the price now for that. So since the Industrial Revolution, I don't know if there's what's that red thing? Is that a pointer? Nope. It's not a pointer. Okay. I don't think there's one on there. But since the Industrial Revolution, we've gone from 280 to 380 to 414 this year, parts per million. We've more than doubled what drove 100 meters of sea level rise from a natural increase. And what would you expect sea level to do? Nothing? Well, it's to go stick your head in the sand and see what happens. And the thing is, what I want to show you today is that it's going to be big and it's going to be quick. The one part that's really important, the Paris Accord was about trying to keep atmospheric temperatures below 1.5 degrees above pre-industrial levels. That's the little red line that you can hardly see at the bottom of all the extra heat that we put into the atmosphere. 93+% of the heat, because of global warming, has transferred to the ocean. So global warming is really heating the ocean. And that ocean is both expanding, rising sea level, and it is getting in around Greenland and Antarctica and doing accelerated ice melt and therefore sea level rise. Okay? And if any of you were born in 1997, as of the last IPCC report that this is from, half the heat has gone into the ocean since 1997. Unbelievable. It would be so much easier if we'd gotten hold of it back then or before. This is a wonderful diagram. It's an attempt at looking at global sea level rise. Oh, thank you. Thank you, Phil. And you can see that global sea level rise from tide gauge measurements doubled after 1930 because of our warming, expanding ocean, and it has gone up since the 90s. It has gone up and is accelerating because we're adding ice melt to that. Okay, and that's the problem. Ice melt is an acceleration phenomenon. This extreme is probably the median, and I'm going to focus on that one because globally we could be at +2 by 2046, +3 by 2059. Wow. If you live on Miami Beach, it'll be over. The problem is that was the global mean sea level. There are 2 things that the South Florida has to worry about, and one of them is the changing speed of the Gulf Stream, which is anticipated to slow down. I can explain that later. But the Coriolis effect has turned the current to the right and built up water in the Atlantic Ocean. As it slows down, here's a cross section here. As it slows down, most of the water is over here, so we will get a sea level rise. And we believe this will be maybe 15 to 20% additional from that global projection. In addition, there's these huge masses of ice on Greenland and Antarctica are actually so massive that they're a gravitational attractor to the ocean, and they pull water toward it. As it melts, it diminishes. And when I first heard that, I said, yeah. Well, there is a NASA video that we couldn't get up and running this morning, but this is the end result of it. Everything was sort of this color at the beginning in 2002, and by 2013, we have had about a just in that 11, 12 years, we've had about a 5 centimeter rise of sea level. That's over 2 inches. And Greenland, because of the melting and the water going somewhere else, because it's less gravitational attraction, has dropped about 5 centimeters, okay? That's real. And that's somewhere between 20 and Isabella Villacogna out one of the California schools suggests for Miami that could be an additional 52%. So this nice diagram I showed you with a frightful amount of sea level by this century, if we add those in, the one on the left has 20% for each, and the one on the right has 15% for slowing the current and 52%. So rather than being at 8 feet, we could be at 11.5 to 13 feet. And again, those projections do not incorporate many of the accelerating feedbacks we're seeing with ice melt. This thing could well spin out of control. Here is Miami-Dade County and Broward County on the top at a 2, 4, 6, 8 feet of sea level rise. We're at this dot here. The other FIU campus is here. And you can see that they and the rest of Miami-Dade County and Broward County are going to get into trouble very quickly. I have put dates on the bottom that could be with the regional influences added in, and you can see that we could be at 2 feet by 2039. We could be at 6 feet within 50 years if these play out. We've warmed the ocean. It's not going to turn around in the short term. Okay, and it's already happened. We've had a foot of sea level since 1930, a little higher than the global average. And these king tides are not incorporated in those maps, and these and hurricane effects that Michael talked about are not incorporated in these maps. Here's present topography. The other FIUs out there, 2, 4, 6, 8, 10 feet of sea level rise. You have to understand how vulnerable Miami-Dade County is, as is Naples. They think it's a Miami problem. Well, there it is. The final thing I want to show you is that the way sea level rose in the past, we have figured out. The way sea level rose from the last ice age to today, as we rose up in the last 18,000 years, that's important how sea level rose. It did not just do this. It did a series of pulses of sea level rise as sea level, one ice sheet sector after another, rapidly disintegrated. And that, all across the continental shelf, we have old reefs, old barrier islands, old tidal inlet complexes that represent sea level. And they suddenly were just abandoned. Our sea level looks like this. And we now have it the whole way. That's how sea level works. Under warming with ice present, you have a warming, you have a rapid disintegration of ice and a 1 to 10 meter pulse in the past. Now, we have risen our CO2 100 times faster, and as I showed you, a lot more. So this is how it's going to work, and so we have to look to Greenland and Antarctica, and they are initiating a new pulse of ice, and this should be a very big and rapid one. Thank you very much.
the panel. So I'd like to invite Dr. Obeysekara.
Check. Can I get my presentation up? I hope it's there. Nope.
Yeah, you can show the rest of mine.
Yeah, let me go ahead and get started while they're starting it. I want to thank you all for inviting me, especially Clio Institute. I've been with them on and off probably for all 10 years. It's amazing the kind of cloud Clio has now. I mean, Michael Mann would not come to any meeting, but to get Mike is an amazing to get Hal. So I'm really impressed with the work they have done, because I always thought educating the public and the young people are very important, and they have been very successful. Anyway, with that, okay, now I got my presentation. I'm also happy that the Sea Level Solution Center that Tiffany and I are involved in, happy to be the partner with Clio on this, and I think it's an important mission for us. Anyway, I think we heard the science very clearly. I'm not going to focus on science, although I worked on sea level rise projections for some time. I'll talk about the implications for the water aspects. Water is very important for where we live. We have, heavily urbanized and agricultural and also natural treasure, the Everglades. So water is very important, both quantity and quality. So anyway, even without climate change, the South Florida is very unique. As you can see, we have very low topography that Hal talked about, high groundwater tables, sandy soils, and very porous geology. And one of the most complex water management systems in the world. And I feel like as communicators, you really need to understand that uniqueness. And I hope to give you some sense of that. So this is the sea level rise projection that we have come up with through the Climate Compact. Hal was part of the committee that I had been with for a couple of times. Now I see David Enfield back there. So, before that, two cities 20 miles apart had two different sets of projections. And we realized we need to come up with what we call sea level rise projection, what we call a unified sea level rise projection that all the communities can use. And we have this. And unfortunately, we have had some science since we produced this last time, 2015. So we are talking about assembling that committee again, or some committee to update that, particularly this paper by DeCanto and Pollard, which came up with this highest projection. So we don't take it very lightly. We know a lot of communities are already planning for this, so we will assemble that committee again and work on it. So in terms of impacts, I always like to think that sea level rise is part of climate change, but somehow in Florida they got separated. And I was in a meeting in Colorado, Kevin Trentberth, he said, "What's wrong with you guys in Florida? Why do you talk sea level rise separately from climate change?" I didn't go into the details why, but so I always think we have natural cycles, and that's one of the things that you hear a lot. But then we have human-induced impacts, land use changes, and particularly the greenhouse gases you heard about. But the other issue is, will these natural cycles be impacted by this new environment we are in? And we as engineers and planners, we think climate is what we call stationary, or we're in a fixed regime. They have natural variability. Now we are in a new environment. So in terms of climate change and water resources impacts, we have to think about four aspects. The temperature change, the rainfall patterns change. I think Dr. Mann talked about that a lot, both extremes and averages. Tropical storms and hurricanes, I think the predictions are sort of dire, and I think what we've seen in the last few years are consistent with those. But more importantly, rising sea level, and I think that's the one that we are already experiencing. So in terms of impacts, all our water resources mission elements would be impacted. They'll have direct storm surge, increasing in frequency, this recurrent or nuisance flooding that we see will become more chronic flooding in certain areas. Water supply will be impacted, the flood protection will be impacted, and natural systems will be impacted. So this is why, and storm surge is one whammy. We may have extreme rainfall, which are increasing, but most importantly in Florida, we have what we call a groundwater table rising due to sea level rise pressure. So we get like impacts on all three sides, and our flooding will get worse, water supply would be impacted, and we have what we call a compound flooding. These compounding effects will make things worse for us. So this is a nice animation that I use. I will not spend a lot of time on that because I only have limited time. So we have these control structures you see in the middle there. These structures were designed and built in the 1950s by the federal government. They did not account for sea level rise. And I asked some guy who worked in the 60s, and he told me his boss advised him, let's leave that problem for the next generation. So guess what, we are here. So we have these structures. When you drive along A1A, you can see these, along the canals. These structures were built to stop saltwater intrusion coming into freshwater wells. But the problem is with sea level rise, sometimes during king tides, we cannot operate these structures because the ocean side is higher. If you open these gates, the saltwater will come in. The problem is if you have a rain event at that time, that there's a potential to increase flooding, and then obviously the saltwater intrusion. So let me explain that in the next slide. So this is what we see. All these blue dots are where the wells are. We get water supply. The red line is actually the saltwater intrusion line. So as the sea is rising, this saltwater intrusion line is going to move faster, or will accelerate towards those wells faster. And you can see that's the kind of rock we have, very porous, Swiss cheese-like. So you can't build levees along the coastline and stop this water. And that's the uniqueness we have. So just to leave some hope, I always think about the time between now and the time that Hal talks about. He always scares me every time I see him. He says he's raising it higher and higher. But I had to think about time between now and then. What can we do in the immediate future and have some hope? So I keep updating this adaptation portfolio, but I will not talk about all of them. So Everglades Restoration, it's a win-win situation. We should all support that. I will bring more water into the Everglades, will help water supply. Water conservation is the best thing to do, low-hanging fruit. We need to conserve water. We use way too much water in Florida because we want to maintain these lawns. Water storage, forward pumping, and more importantly, natural infrastructure. We should look for ways to protect the beaches and the coastline with natural infrastructure like dunes. So there are a lot of things we can do, but at some point we are going to hit that tipping point. We need to rethink if we are going to survive in this kind of environment. Okay, so I'm going to wrap up. This is a graphic, and this is the compliment to the people in South Florida. They actually have, through the efforts of the local governments, the consumptive use or the water we use, what we call per capita water use, gallons per person per day. In 2000, it was like 180. Now we are at 140. We should be more like 60 or 70. But I think that's the good news. People are hearing, and that's a message you can communicate. With that, I will stop here. I think I made my 10 minutes, but I can never give a 10-minute talk.
Hello. Can you guys, does that work? Okay, great. All right, so we're going to have a panel.
And the derecho, of course, took out power. And suddenly, you have this record heat and humidity and no air conditioning, no power. So sometimes we find ourselves in situations that we might not have gamed out until we see it happen. Another example of that is in California a year ago when we had this record wildfire season. And these wildfires in Southern California destroyed a lot of the vegetation in parts of Southern California, in the Santa Barbara area, and that sort of destabilized the topsoil because you didn't have that vegetation holding it together. And then what happened? You got a winter storm coming through, and by the way, as the atmosphere warms up, it can hold more moisture, so those winter storms pack a bigger punch, and you get more of those flooding rains, something I alluded to earlier. And so now all of a sudden you have these intense flooding rains interacting with destabilized topsoil, and you got these catastrophic landslides, mudslides. And again, it's the sort of thing that you might not have gamed out. We might not have predicted that. But once we see it happen, we realize, oh, okay, yes, these factors can come together. So I suppose the interaction between these factors can lead to new challenges, and I suppose the game here is to identify them. We're not going to be able to predict all of them in advance, but when we see it, to learn from that, to understand the underlying processes, how they can interact to lead to new types of catastrophes, new types of disasters, and do our best to constantly adapt to those changing conditions while at the same time doing everything we can to prevent further climate change and further warming. It's not either or, as my good friend John Holdren, who's the former science advisor under the Obama administration, has described it. Our response to climate change is going to be a combination of three things: mitigation, adaptation, and suffering. And it's up to us to determine how much of each of those we wish to see.
Called a wet bulb temperature. In Phoenix, you can sweat to cool down. But if it's humid and it's above 95 degrees, you die, sort of. I mean, you don't really, that's true, you don't have a way to cool down. And so what the condition he was describing is a catastrophe. And that's the real danger. And Miami area, or South Florida, is forecast by mid-century to have 80 or 90 days more above 90 degrees. So, yeah, that's not pretty. The second one is, the last two slides I didn't get to, talk about cleaning the land before we leave. We will be inundated in South Florida. That is not turnable, aroundable. We've warmed the ocean, and ice melt has started at an aggressive pace. And you go down and look at Mount Trashmore. It's 145 feet high. It's huge. And all along the coast are these low-lying dumps. And what are we going to do with that? Are we going to let it be ripped apart by the raging seas and the tides and the storm surges and the waves? Or are we going to do something? Are we going to clean our industrial land? That's another catastrophe that's going to be superimposed on all these things we've talked about if we don't take the responsibility and provide a clean, new, shallow marine environment for our children.
Thank you. Okay.
Yeah, I'll make quick comments. I think I'll focus on the flooding and the compounding effects of sea level rise, storm surge, groundwater level, and rainfall. This is where we need to think about, we really need science input into resiliency planning. And I think that's very important, how to deal with these compounding effects. Unfortunately, we don't have a whole lot of data to understand this relationship. So this is where one of the things we are doing at FIU is Florida Building Commission has asked us to come up with new groundwater level maps. So the building code could be changed. But more importantly, we are trying to see, can we generate some synthetic events of hurricane coming through, increased rainfall, groundwater level, and understand what is the probability of these things happening together so we can provide that information for resiliency planning. I think that's my basic point there is like we really need the science input for resiliency planning.
Absolutely. Thank you. So how about we open it up to a question from the audience? I see a gentleman way in the back there with his hand up first. Yeah, that's you. Do we have a mic for this
Yes, I
gentleman?
do. I have the mic.
Great.
I'll be right there.
Okay. All right, I'll be patient. Want to get as much information out as possible during our discussion.
Thank you. Good morning. Good morning. Thank you very much to each of you and also Cleo for bringing this forward. It's a really enriching and absolutely scary circumstance you present. But we were just a couple of nights ago at the Rosenstiel School of Marine Biology in Miami, and they were talking a lot about the issues with the blooms of algae and so forth that we continually have and they continue to grow. And I wanted just to come back to the issue of restoring the Everglades. Because as we all would like to have that happen, under the current circumstances, the sugar lobbyists have done so well that our Lake Okeechobee is so nutrient rich that it's just full of algae blooms. So when we have the water run off and it starts going south and it starts moving down into the Keys, not only does it have a disastrous effect on the sea life, but it also has a disastrous effect, knock-on effect, if you will, to all of the scuba diving that happens down there because the visibility is completely gone for the entire summer. So there really are serious knock-on effects and other issues, but I don't know how we resolve this issue with regard to the Everglades and fresh water flowing properly down through that amazing body of water. Perhaps you could share some ideas on that. Thank you.
Well, if I could, there are two problems I see. The first one is that an unnamed former governor, Rick Scott, didn't permit or didn't demand cleaning of the water coming into Lake Okeechobee. There's a huge number of over-fertilized cattle fields and so on north of there. And so we've just created this monster problem. And that should be cleaned before it even gets to Lake Okeechobee, and let alone afterward. The second thing is that during rising sea level, times of rising sea level, all through geologic history, it's a time when you're recycling and eroding all the coastal mud and organic soils and peats and producing huge amounts of organic matter and nutrients in the coastal waters. And that's happening now along the southwest coast of Florida. And that excess of nutrients is working its way down through Florida Bay, through the gaps in the Keys, and out across the reefs. They're excellent aerial photographs or satellite images to show that. And that's a huge problem. And that's not much we can do about it. But that's pretty well documented now, and that's all through geologic time.
I'd be happy to add a word or two here. This is another good example of how we have these compound factors that can exacerbate an event like a red tide, an algal bloom. And climate change is one of them. Warmer waters, greater anoxia, that favors these conditions. And so when it comes to dealing with some of these environmental threats that Florida is dealing with, like these red tides, it's a matter of attacking multiple problems at the same time. It has to do with agricultural practices, it has to do with water use policies, but climate change is once again a threat multiplier. The warming oceans favoring anoxia and the sorts of conditions that give rise to red tides, climate change is exacerbating that problem as well.
Real quickly, having worked on water management for years, that's an important question, but I see some really good signs right now. Number one is, first we have to recognize Lake Okeechobee is a highly constrained water system because people depend on it, agriculture depends on it, environment depends on it. So the operation is very complex, but the good news is that the Army Corps of Engineers is revisiting the operations of Lake Okeechobee right now, and this is a good time to provide input. And the other good thing is that the Water Management District has asked a scientific committee to provide input to the Army Corps efforts, and I'm one of the members of that committee where we will look at the water quality issue and also the water quantity issues, because at times Lake Okeechobee in one wet season get 5 feet of water during very wet years. And that shows that you really need bigger storage, pretty much everywhere, to store that excess water at times without basically blasting the estuaries to the east and west. The last good news is that the current new administration has recognized this as a really important issue and working on to address both quantity and quality by having the storage. So I think we should all support that and be active in making sure that this estuary is addressed by having more storage to store that excess water.
Great, thank you very
Thank you.
much. Another question, this gentleman?
Two questions. I have two.
Oh, I'm sorry, I didn't see you. I apologize. Please go ahead.
I share your sentiments, Dr. Mann, because my name is Michael too, and it was the worstest time I had last year, thinking about what their hurricane was doing.
Can you speak closer to the mic? It's a little difficult to hear.
Okay. My first question is about gentrification and the effects that it's having, increasing the carbon, the impact that these developments are having. The second one deals with the water question. We know for a fact, it's been documented for years, that our waste is a personal waste. It's not so much cities and states, but it's how we are in our households. You know, if you're taking a shower over 7 minutes, you know, you're using like about, 15 gallons of water? And that's one of our major wastes. So I hope that you can talk about that, particularly about that, the carbon intensity, the impact that these developers are having in especially low-density areas.
Yeah, thanks. I'm happy to tackle a piece of that, and I'm sure each of us can tackle different pieces of those questions. You know, sort of revisiting an issue that I sort of touched on in my talk, you know, personal responsibility, personal actions are an important part of the problem. When people ask, what's the solution? Is it personal action or is it collective action and policy? It's a false dichotomy. It's both. And certainly there's so many things that we can do to reduce our waste, our generation of waste, our you know, wastefulness when it comes to the use of water, electricity. The more we conserve when it comes to resources, the more we help sort of move towards a sustainable environment. So, you know, that's low-hanging fruit as far as I'm concerned. Being, you know, making greater use of our resources, producing less waste, you know, means we're being more efficient with our, you know, with the money that we have. It's good for us, it saves us money, and it's good for the environment. So we should all do those things. But we also need policies that incentivize increased conservation. And sometimes that's a challenge because there are industries that profit when we are wasteful with respect to our use of food and water and electricity. In fact, they encourage wastefulness. Get an SUV. You want an SUV, not a little fuel-efficient vehicle. So there are these external forces that are pushing us towards being more wasteful. And we need policies that disincentivize that sort of larger corporate behavior that leads us to decisions that are unfavorable when it comes to environmental sustainability.
Thank you.
Yeah, I think you had asked about two or three things. So let me address those first. I agree with Dr. Mann that I showed that graph of the water conservation. I think if you use less water, that means less water would go into our wastewater system. The problem is with sea level rise, groundwater level coming up, and some of these individual septic systems could be affected. Miami-Dade County Resiliency Office produced an excellent report on that. And I think the key for the long term is to have a regional wastewater treatment system so we don't let that water go into the groundwater and eventually could seep into our, you know, Biscayne Bay and others. So that is one area. Water conservation is something we can all promote as communicators. I think that's another thing that we could find other ways to reduce that, bring that curve even further. And finally, on the gentrification, that's a really important question. As these coastal areas get wetter and wetter at more frequency, you know, the development will move inland, particularly to the higher grounds. And I think that's where the policies will need to be developed, and especially in case of long-term planning for land use changes.
Yeah, I'd like to torque that question a little bit and talk about, should we be spending money on defenses as sea level's rising at an accelerating rate? Or should we be setting aside money to help with relocation? This is really important. You've seen Miami Beach spend, I don't know, $500 million or whatever, raising a few roads and making life awkward in a way for some parts, a very small part of Miami Beach. Is that the right expense of money? Are they going to get a payback on that? That's borrowed money. Or would that have been better put aside or borrowed to help with relocation? You know, if you relocate and turn the low areas into green space, you no longer have to maintain infrastructure there, which is a huge cost, especially as it gets more difficult. So Americans seem to hate the idea of helping me relocate, but that's un-American apparently. But maybe it's cheaper, you know? That's really something to think about. We will be moving on.
Thank you. One question over here. We have about 5 minutes before we get to our break, so I've identified 1, 2, and 3 more questions. If we can, we'll get to more. Thank you.
Hi, I'm Ariel Rodriguez, a meteorologist from Telemundo 51 here in Miami. I was very impacted by Dr. Harold Wanless' presentation. I mean, I know what sea level rise will do in Miami, but your graphics were very outstanding in sending that message. And what struck me the most was the short amount of time that we might have for that change to happen, especially for, let's say, like a mortgage, which is like 30 years, and that impacts people a lot. So we see in Miami now, we see it every day. We see cranes, we see constructions, buildings going up constantly everywhere. At what point do we think it becomes unethical to continue building in a place that within the next few decades will have all these impacts? And also, are the people with the political power to take action aware of this? Are they turning a blind eye to this? And we as communicators, what else should we do in order to get this message across?
Well, ethical, probably last year was the last time we should ethically be doing this. This is real and it's happening. And as I said, and it's a learning process for us. In 2007, this task force to the county, we upped from the IPCC projections that won a well-deserved award for Michael Mann and the others writing it. But we said it would be 3 to 5 feet by the end of the century. Now it's obviously going to be much higher because we're seeing what ice can do. We've never seen this before. And I don't know, it's just, there is no warning. There are already places in Miami-Dade County where you can no longer get a 30-year mortgage. And you just watch the next decade in flood insurance, because it's not paying for itself right now. And you put those two things together, and the house you just bought on a 30-year mortgage, you go to sell it, you can only sell it on a 15-year mortgage. It's worth maybe half as much, I don't know. That's going to be a shot in the face for your nest egg. So it's starting to happen, and there are more and more young people renting, and there are more and more people come up to me and said, I just sold 3 extra properties I had in the Keys and made a killing. Well, there's no warning when you buy right now, and that's wrong. That's the ethics part.
Maybe we can squeeze in one last question here.
Yeah, okay.
We'll do
sure.
a lightning round of responses.
All right, real quick. All right, thank you guys for being here. My question is actually, we know that millions of people currently are being affected by droughts and stuff when it comes to food security, but I was wondering if any of you on the panel knew how saltwater intrusion in the future would affect agriculture and food security internationally, and what effect that would have on the masses.
Dr. Mann, or maybe Dr. Obeysekara, you do some work on water resource management.
Look at our deltas of the world. That's where the problem's going to be as sea level rises. That's our food basket.
You know, very short. Clearly in Florida, you know, if your well field is contaminated by salt water, you need to look for alternative sources. Where do we go? We build some storage to store that excess water and use them, or move the well field inland, but you can't move it towards the Everglades because then it will affect the Everglades. But there is one solution that will cost more is to basically desalinate the brackish water. So there's enough water, but the cost will be more, at least in our region. But globally, in certain areas, if you're going to have more droughts, it's going to significantly affect the agriculture and water supply. And there needs to be ways to conserve water and find alternative water sources.
Yeah, I just have one thought to add to that. This is a great example of the cost of inaction, the cost that climate change is already, the toll it's already taking, and the further toll it will take. And so when you hear people say it's too expensive to act, it's too expensive to act on this problem, just the opposite is true. And this is an example of just how expensive it will be for us not to act.
Thank you. We have about 2 minutes. There's so many questions, but then how do I resist that little face over here? Oh my goodness. Okay, you came all the way from Denver.
So I would like to ask about how are we going to handle the population coming from those coastal areas into the higher up, less threatened areas?
Like Denver.
Yeah.
We're all moving to your house.
Thanks.
Don't move to Denver, there's too many people there.
Thanks for that question. There's a town in central Pennsylvania called Jersey Shore, and I'm sure there's a story behind it. And I tell people that you're probably safe in Jersey Shore, Pennsylvania, but if you vacation at the Jersey Shore, you're in trouble. And for all those people who live along the coast, this sort of raises, again, the specter of national security implications, conflict, environmental refugeeism. This isn't just a theory of what can happen, it's already happening. We see it in Europe. Just 1 million people from Syria flooding into Europe has created an international conflict crisis and has led to sort of the rise of nativism in the politics of countries around the world. You see similar things elsewhere. Even in the United States, there's some evidence now of environmental refugeeism within the United States. People fleeing the coastlines. The North Carolina coast was devastated by Florence. The crisis when it comes to immigration, if you believe that's a crisis, well, that's environmental immigration. The people coming up from Mexico and Central America are fleeing lands that are no longer livable. And so this is already coming to a head. And if we, again, allow this problem to grow in magnitude, we are going to see the greatest conflict/national security crisis of all time. Literally hundreds of millions of people fleeing their homes. And it doesn't matter where you live. If you think you're safe, if you think you are somehow insulated from the impacts of climate change, no place will be safe. No place won't feel the impact of growing global conflict from a competition between 7.7, 7.8 billion people and growing on a finite planet with finite resources that are being made more scarce by climate change. So the short answer is if you care about issues involving population and resource depletion, climate change, once again, is the greatest threat we face in that regard.
Yeah, you bring one of the most important questions. We're just going to be leaving. It's those places we're coming to. Are they preparing for us? Or they're setting aside water resources and the preserve areas they don't want us trampling and things like that? That's where the real focus should be, on those upland communities. And finally, I give a handout at all my talks, including my 10-minute ones. But I didn't want to print it for 200 people, so Cleo's going to be sending it to you electronically.
Yes, we can definitely do that. Thank you so much to everyone on our science panel.